Hello and welcome to Kognito Key. Today we're going to unravel a really fascinating puzzle that's hidden deep inside our digital world. It all comes down to a special way of counting called gray code.
Okay, let's dive right in with a question that might sound a little strange. Why on earth would counting from 7 to 8 be risky in a digital system? I know it sounds weird, but trust me, by the end of this, you'll see why it's not nearly as simple as it looks. So, to get our heads around that risk, we need to talk about the language computers speak, binary code. You know, it's the foundation of everything digital, built from just zeros and ones. But this system we rely on has a hidden weak spot, a little glitch that can cause some pretty big problems. Now have a look at this. The really interesting part is the jump from the number 7 to the number 8. In binary, 7 is written 0111, and 8, that's 1000. Just look at that for a second. To get from 7 to 8, every single one of those bits has to flip completely.
That's right, 4 bits, the entire number, all have to change at the exact same time. Now, in the world of high-speed electronics where timing is absolutely everything, that's like trying to get 4 musicians to all change chords at the exact same nanosecond. Yeah, it's just asking for trouble.
And here's the real problem. If even one of those bits is a tiny fraction of a second slower than the others, for that brief, chaotic moment, the system can read a totally wrong number. This instability is what creates glitches and errors, especially in really sensitive systems.
Well, this exact problem of instability is what led an inventor named Frank Gray to come up with an incredibly elegant solution. He designed a whole new kind of binary system, one that was built from the ground up to prevent this cascade of changes. So, it's time to meet the hero of our story, gray code.
The absolute superpower of gray code is its one-bit change rule. It's so simple. In this system, when you count from one number to the very next, only a single bit is ever allowed to change. That's it. This one simple rule makes the whole system incredibly stable and reliable.
And here it is, the big aha moment. Let's look at our risky 7 to 8 transition again. In standard binary, it's that messy 4-bit flip. But in gray code, the value for 7 is 0100, and for 8, it's 1100. See it? Only 1 bit changes. It's just so clean, so simple, and basically error-proof.
Okay, so you're probably thinking, this is really cool, but how do we actually make these gray codes? Well, it's actually much simpler than you'd think. Let's walk through how it's done. It's just a few easy steps. All right, here's the simple recipe. First, you take the very first bit of the binary number. We call that the most significant bit, and you just copy it down. That's it. That's your first gray code bit. Then for the rest of the bits, you just add adjacent pairs from the original binary number. Just remember these simple rules. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and the special one, 1 plus 1 is 0. You just keep doing that all the way to the end.
Let's run through a quick example together. Our binary is 110101. So first, we just copy down that first 1. Now we add the pairs. 1 plus 1 is 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. And last, 0 plus 1 is 1. And there you have it. Our gray code is 101111. See? So fast and simple.
Of course, if we can go from binary to gray code, we need a way to go back, right? Back to the standard binary we all know, and luckily that process is just as logical and just as straightforward. Now the rules here are a little different, so pay close attention. Again, you start by just copying that first bit straight down. But this time, you add the binary bit you just found to the next bit over in the gray code. It's this sort of diagonal addition process as you move along. All right, let's try it with this gray code. 101011. First step, copy down the 1. Now for that diagonal addition, our new binary 1 plus the next gray bit, 0, gives us 1. Our new binary 1 plus the next gray bit, 1, gives us 0. Then, our new binary 0 plus the next gray bit, 0, gives us 0. Next, 0 plus 1 is 1. And finally, 1 plus 1 is 0. So our final binary number is 110010.
So all of this is a very clever mathematical trick. But where is it actually used? Why does it matter in the real world? This is where gray code really goes from just a neat concept to a critical piece of technology.
You'll actually find it in digital communication systems like digital cable TV, where it helps cut down on transmission errors. But its most classic application is in something called a shaft encoder. These are sensors that measure the exact position of a rotating shaft, like in robotics or big industrial machines. By using gray code, these sensors avoid those dangerous glitchy states as the shaft turns, which means they always report the correct position.
So really, the crucial point to take away from all this is that gray code is such an elegant solution to a really complex problem. It's a beautiful example of how a small change in how you look at something, in this case counting by just one bit at a time, can make our digital world more robust, more reliable, and way less prone to error.
And that kind of makes you wonder, doesn't it? Gray code is just one example of something working silently in the background to keep things running smoothly. What other invisible codes and clever algorithms are out there, quietly forming the hidden foundation of our modern world?
I really hope you enjoyed this deep dive into the world of gray code. If you found this explainer useful, please hit that like button, share it with someone you think might be interested, and of course, be sure to subscribe to Kognito Key for more explainers that unlock the secrets of science and technology. Thanks so much for watching.